Calculating heat. So far, we have considered the effects of heating a substance in qualitative terms, and we have given an explanation in terms of a kinetic model of matter. Now we will look at the amount of energy needed to change the temperature of something. When the temperature of a system is increased by supplying energy to it, the increase in temperature depends on the mass of the material we are heating, the temperature change we wish to achieve, the material itself. We can represent this in an equation. The amount of heat Q that must be supplied to increase the temperature is given by heat is mass times specific heat capacity times temperature change. In general, we can write the equation of heat as Q, changing thermal energy in joules. M, mass in kilograms. Specific heat capacity in joules per degree Celsius per kilogram. Change in temperature in degrees Celsius. The specific heat capacity, or simply specific heat, of a substance, C, is the energy required per unit mass to raise the temperature by 1 degree Celsius. If the mass is measured in kilograms, the unit of C is joules per kilograms per degree Celsius. Specific heat capacities of some materials. You should notice that the specific heat of water is much bigger than other substances. Pay attention in this example. 1 kilogram of water needs 4,200 joules to increase its temperature by 1 degree Celsius. And 1 kilogram of copper needs 380 joules to increase its temperature by 1 degree Celsius. Water needs much more energy to increase its temperature by 1 degree Celsius than the same mass of copper. This also means that when water cools by 1 degree Celsius, it gives out more energy than the same mass of copper cooling by 1 degree Celsius. Water needs lots of energy to heat it up and gives out lots of energy when it cools down. Another interesting example. Water has a higher specific heat than sand, so it requires more energy to be heated. This is why the ocean is always cooler than the sand on the beach. This high specific heat of water is very important to us. We are made mostly of water. A high specific heat of water means that our body temperature does not increase too much when we take exercise, or cool too quickly when we go outside on a cold day. Let's see how the heat equation works. Mass in kilogram. Take the heat equation and substitute the values given the question. Another question. Take the values given in the question. Let's remember a little about the power. In this example, the heater transfers thermal energy to the water to heat. Change energy transferred by heat. Substitute the values into the formula. Another example. When two substances at different temperatures are mixed, heat flows from the one at the higher temperature to the one at the lower temperature, until both are at the same temperature, the temperature of the mixture. If there is no loss of heat, then in this case, heat given out by aluminum equals heat taken by water. The heat lost is represented by the minus sign in front of the equation.